So good evening, everyone. Please, can you guys hear me? If you can hear me, please leave a thumbs up or just signify in the chat box. Thank you very much. Okay, and you guys hear me? Okay, thank you very much. So today we are going to be looking at Docker, and I'm going to be making a few assumptions here. The assumption will be that you have an idea, a working idea of Linux and the operating system, and that you also understand, say, the command line, and common Linux, what would I call it now? Common Linux commands. So I won't have to explain everything through it all. So yeah. So let's see. So this is going to be, I'll take this as a more of an introductory class. Introduction does not mean I'm going to stick with just the theory alone. So we're going to look at everything holistically as much as we can over the next 2 hours. We are going to be looking at, say, Docker and the containerization of everything. We're going to be looking at Docker images, containers, and maybe how to write a simple Docker file. So yeah. So someone is speaking. Please speaking. So I'm going to share my screen right about now. And share screen. And so let's just so I'm going to be looking at it all. So yeah, I am going to assume you guys have Docker installed, and I'm going to be making a lot of assumptions. But if you have any questions, please leave them in the chat box and signify, or just let me know if I've lost you anyway while we're talking. So one of the many things we would be using interchangeably might be containers and Docker images. And while they might be the same thing in themselves, they might be the same thing, but what you have to understand that an image is a static container. Static in this means it's not running. It's basically a template for which a process is going to be based on. A template for which a process is going to be based on. Let's just say we have a front end image that's going to be saying we have built a front end image, and if we were to run that, it's going to become a container. So a container is a running image, while do not use static as it's the technical term here, but I'm trying to make you understand it as much as possible. While an image is a static, okay? So you think of an image as a template and the container as the running process on which that is based on the template we have or someone else may have done at that point in time. So the idea of containerization is you have had certain developer jokes where someone says it works on my system, but does not work on the other person's system. It's that kind of thing. And as a DevOps engineer or anyone using say Docker as a tool, the idea is to ensure that whatever you are doing on PC A or system A or server A is going to be the same for all other servers, regardless of how would I put it now, regardless of their operating system. So if I were to containerize something on a Mac and I'm going to send it to share it with a friend using a Windows PC, another person using or Linux, yeah, it's essentially going to run the same way. So that's what Docker eliminates that segregation of some sort, because when you see certain processes working a certain way on a Mac, it's not going to work the same way on your Linux or on your Windows PC. Docker relieves you of that stress, that headache. So there are several benefits to using Docker, and one of which would be, same thing, like you are trying to be isolated, you're trying to isolate processes. So you could have, let me see if I can pull up something, an image here. But I'm just going to write some things down, so we're going to get used to them. So hopefully this comes here. So the idea is that when you're using Docker, you want to isolate processes. So if you have a front end and a back end and a database, what would I call it now? And a database container separately. Let me find somewhere I could draw this on. Let me see. Draw. Draw. So I'm just trying to see if I can make certain things very, very vivid as soon as we go, just on device. So create new blank. Just put it somewhere over here. So let's assume this is, let's call it the Docker container. Let's call it another Docker container. And this is a third container. So what you should know that these guys here, let me find these guys here, they are all in one OS. Let's say this OS it could be, say Windows OS. Let's just call it that. Let's just say it's a Windows OS. All of them here, they are all individual, say this could be front end, back end, and your database images or containers running concurrently within your Windows PC. What you should understand that they are all sharing the same resources within the within the Windows machine, but what they have is an isolated environment. So what's working inside here is not going to interact with what's working inside here unless you make certain configurations possible. So what you are going to do, what's happening, that you have everything to make it as much as you want it. So that's the idea. And some people also make the also confuse, like, how's a Docker container or a Docker different from a virtual machine? That sort of thing. The idea is that a Docker container or Docker itself abstracts on top of an OS layer. So it does not have its own OS or its own operating system. It abstracts on top of it. So what you have here is that it is having its, this may have, it's only branching on the OS layer of this machine. So it's working on Windows. But there, for Windows system, before you can download, the CLI portion of Docker, you have to have WSL installed, the Windows subsystem for Linux. That's like a bridge. You're trying to bridge your Linux system to work on your Windows machine. Then Docker then rests upon it. So that gives you an idea of what the abstraction is in this case for your Windows machine. So I don't have to state that it's applied over your WSL, system WSL. No, I am only saying, when I say Windows, you should understand what I'm trying to talk about. So it is abstracted over your Windows machine, even though WSL is like a template shielding it from your Windows machine, because WSL is just giving it that ground for it to be able to connect with your resources. It's almost like I am trying to convert from pounds to kilograms. That conversion in that sense, even though that's not the technical term to use, that conversion in that sense, that's what the WSL is doing for you in this scenario. But what does how's virtual machine different? Virtual machine it only allows the hardware isolation. So if this were a virtual machine running here, that means you are going to be having a separate operating system within itself. So you can have your Windows machine here. See, it has a virtual box, and inside here you have a CentOS here. Inside here you have a say Red Hat Enterprise Linux. Then you have Ubuntu here. All of them are going to be separate operating systems. But the thing here is this makes it heavier and slower to get booted up. So if you want to run it, for instance, you want to boot it from scratch, it's going to take a long while to boot everything from scratch. But there are a lot of things that you have to you are going to be looking out for. So that's like a difference between Docker virtual machine. So the OS level has so to give you more context, the operating system level, operating system has like two layers, the kernel and the application layer. That's what it is. So Docker virtualizes on the application layer. I'm just trying to give you like going into more detail, give you like the more technical aspect of it. It virtualizes on the application layer, is using the resources for the OS is allowing to use. While VM virtualizes on the OS kernel. So it's more of working on the hardware of your PC. So that's why I'm trying to let you know that one isolates the hardware, the other Docker isolates the application on the operating system. So yeah, does anyone have any question? I can hear someone trying to say. So guys, please mute your mics if you are not asking questions. So that's one of the reasons you may. So now that we have been able Docker versus now that we've been talk about this, just so that Docker is smaller. Docker is smaller in size. So that's like one of the advantages. So you'll have the ability for, if you're going to build your own Docker images, you have the ability to shrink as much as possible the size of your Docker image. So Docker is really smaller in size. So you have it's very hard for you to see a Docker image that is several gigs large, unless it's such a huge application. And even then, their best practice to minimize that. But for your virtual machines, you're going to see something that usually very large, several gigs at say 3-4 gigs. It all depends on the operating system of the virtual machine. Then Docker is much faster. Docker is much faster because it's lightweight. It is much faster. It's even easier to boot up. Much faster and easier to put up. So that's another advantage. Then let's see. Well, even though we have said that Docker runs on Windows, Docker the VM of OS can run on any OS. So let's say, for instance, the virtual machine of your OS can run on any OS, but not the Docker. So what I'm trying to say is this. Before now, Windows machine could not run Docker images. They had to be like a long workaround for that. But until recently, when you had the WSL, that's when you could now run, images that are based off of Linux. So if you do not be surprised if you have your machine is lower than Windows 10, which I doubt anyone here has, you cannot run Docker machines, most Docker images. So that's going to be an issue. So you should have that at the back of your mind. See, if something is not running as it should, you could ask yourself, oh, what's the OS of my machine? But I don't think anyone here is using like less than Windows 10. But I just thought to throw that out there. So well, Docker popularized the use of containers. Like containers has been like a nascent thing within the development industry. Like people are trying to package applications much safer, much better as artifact. So while you may hear things like artifact, think of Docker is just the containerized version of an artifact. So I'm going to explain what artifact is. So you have a Java application or any other language application, and how do you want to run it? You could choose to just run it or build it up. So the build, whatever you build is called an artifact. So every Docker image is an artifact in some sense. So that should give you like an idea of what I'm talking about. So all of them are artifacts. But then again, you can Dockerize artifacts so that they become images in themselves. So we are going to see, hopefully, if we get to that point in this during this point of the class, we are going to talk about them. So when you install Docker, what you essentially install. So when you install Docker, what you install is the Docker engine. And the Docker engine has 3 things, working for it. It has the server, What it also has is the API, and lastly, the CLI. So what does the server do? What the server does is this: it pulls images, it manages images, and the containers. So when you pull images, pull and manage images and containers. So yeah, that's what Docker server does. Then for the Docker API, it interacts with the Docker server. So when you, sorry about that. So when you're writing your command, say Docker PS, Docker LS, all that stuff, the API portion of Docker is what interacts with the server to output what you want to see based on your command. So the API interacts with the Docker server. Interacts with the Docker server. And lastly, we have the CLI. The CLI is the client that execute the Docker command. So what's going to happen is when I enter into the Docker CLI and I am trying to execute the Docker command, execute Docker commands. When I tell the CLI, I try to execute Docker commands, what happens is that the API goes to the server and says, oh, here's a command I was written. So based on what you've entered into the Docker CLI, that's what it's going to pull from the server and output to you on your CLI. So far, so good. Do we have any questions, or are we good to go, please? If you are good to go, please leave a thumbs up. If you're not good to go, you could write your question in the chat box, or just let me know right away before we move on. Okay, everyone seems to be on the same, so thank you very much. Then, I think we all have installed Docker. I'm just giving that, giving that. And let me give an example. So let me see. We have Docker images here. So we have several Docker images here, so several of them. And if you are trying to look, so it's the same thing. So the Docker CLI here executed this, and the API took this command and went to Docker server and says, this is what I've been asked to do. Then the Docker server returns based on your query, and the API through the CLI outputs these things. So that's like how it works. So it's like a 3-way process. And sometimes, because of how cumbersome the whole deployment process can be, because using containers and deploying large-scale applications can get pretty complex quickly, especially for things like that uses big data or for streaming services, that kind of thing. You may not have to use Docker all the time, because Docker is like you have three in one. Like sometimes you just want to store a certain portion of the container and just go on with it. So right there we have alternatives to Docker. To Docker. So if you want to just build images, you are not thinking of running on anything, you could use things like Builder, and you could use, if you are interested in the runtime alone, just the runtime alone, you just want to run, you don't want to do other things, you don't want to build, then you can be looking at things like Containerd and Cryo. There are several others. But the thing is, if you install Docker, when you're installing your Docker, if you look carefully when you're trying to install Docker, you're going to see like Containerd is one of the things that you are installing along with Docker. So this is the container runtime. And over time, it has moved on from, so let me give an example. So when you're trying to deploy Docker containers with Kubernetes, before now, it was running only with Docker, like it used to run only with Docker. But the idea is that there are several other alternatives to Docker. So the idea was to strip away the runtime and from Docker and make it that anyone can use it, but we'll still have Docker, yes, but the runtime can be used by anyone who wants to use our runtime. So that's where containerd comes from. So it's like a pretty robust history. You can just go back and look on it, just in case you want to, have more idea about that. So let's see. So if you were to go on here and go to Docker Hub, let's just go to Docker Hub. Docker Hub is like GitHub. It's where you store your Docker images that you have built, and it's also where you are going to be pulling Docker images from. And just like GitHub, how organizations have like their own private repositories or organizations, that's how within Docker as well, people have that as well. So if I were to come here and say, oh, here's Nginx, and I want to see, for instance, my IP address. Let's see, let me see IP config. Sorry. Let's see. So I may want to enter this guy here and say, let me see what's going to show me here. There's Nginx already installed. I'm trying to, but let's see if there's a port 3000. So there's really nothing on port 3000, and we're going to work on that later. But I'm just trying to give you like a head start. So if I were to pull Docker image, for instance, like Docker image from here, I can decide to do Docker pull Nginx, and I'm going to pull Nginx from Docker. But what we are not doing here, even as we did not, matter of factly say this is the exact tag or the exact version of Nginx we're trying to pull. What Docker does is, since there's nothing attached to it, it comes here and says, let's look for the latest, and we're going to pull it. So this is the latest. So what Docker reads as is what you are saying. You are essentially saying this. That's what Docker is reading this as. So that's one of the ways that you can go to using tags. So you should have this at the back of going. So I can come here and say, I don't want the Nginx latest one. I want the, say, one Perl, and it's going to pull it as well. So now you should understand. Now this is such a cool thing to see. If you see here, when I was pulling the Nginx, image, you can see that it pulled these things in layers, like there are several layers. They are abstracted in several layers, and it pulls all this and it kind of extracts it. But when I was pulling the Perl thing, so basically most of the time, a lot of the layers of the images are similar. So what it does is it's going to look at what it doesn't have and pull that portion. So you see, it says these layers it already have them. But what it's going to do is going to add the layer it doesn't have, the layer that is not present here. And that's where you see that this is the only guy that says pull complete. The rest says already exists, because if you notice 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So these guys were already here before by virtue of us just pulling the latest Docker image. And we saying this is what we want to pull. Maybe this layer is the only layer that differentiates this guy from this guy. So that's how like Docker thinks work. So even if you are going to be building Docker files, Docker images, that's how a lot of things are going to work. So if you have a lot of things already on your local machine, it's not going to take too much time to build. So that's us just getting started. Then we could come here and say, I can come and say Docker. Let's check with Docker images and see we have several images now. So we have the latest. If you notice the tag. So when you say Docker images, it's going to show you the repository, the tag, the image ID, when it was created, and the size. And let's go into this. So when you see here, there's a name attached just before the / before the Java app. This name attached. This name attached is my repository on Docker Hub. That's it. So just as the same way you have the name of the username of your GitHub repository, that's how you have your username. for your Docker hub. That's how it is. So unless if you don't specify a username before the app you're trying to pull, it automatically states that, oh, I'm going to look for something here on Docker Hub. I'm trying to pull it down. So if I do Docker pull Java app, it's going to go on Docker here in Docker Hub and look for Java app until you find something. And I'm very sure it's not going to say anything because there's nothing like Java app unless it's someone else's repository. And how can you find that unless you attach a repository here where there's a Docker, Java app, and you most likely would be able to move that unless you have what's it called, the credentials of that repository. So that's it. So the tags are usually one of the coolest ways. So you know how you are trying to upgrade your applications on your phone or anywhere else. That's the idea software developers and software engineers tend to look at tags. So I may have committed the code to GitHub and we have built it up. Say that's like the fifth iteration of the app. And I want to be sure that this one is different, even though they are the same size. How can I tell they are different? If you notice they're the same size here, so I could just add. It could be you can add the tag. It could be based on the runtime of the CI/CD tool we are using. That's on that topic. It could be based on previous version. Say we had a previous version 4. We can decide to name the new version where we have made the Docker container or Docker image as version 5, and that's the tag for us here. Is the way that we tend to differentiate the different binaries and images we have built. And the image ID is very, very simple. It's what separates this guy from the rest. So you can instead of using the name to start a container, you can use the image ID to start and delete a container, or even stop it a container. So that's it. So the image ID is the identity of the this, even though this may serve as a domain name set as a DNS. No, I'm just trying to make like an analogy here. Just as you have IP address and your domain name, that's how you have your image ID and the name on your for the repository. So if that makes sense, we'll just move on to something else. So let's see here. We can start. Let me see. Should I start this Docker? So we can start this now, and let's see. So let's see if we can start this guy here. Let's see. Let's just Docker run. Oh, you can only use start when you have stopped an image. So Docker run. Which tag would I want to start? Let's say Docker this. And there are several commands to do to starting something like this. You can use the D. The D means detached mode, and I'm going to tell you why we use detached mode most likely, sometimes. But I'm going to show you the difference between that and this. So we can say I'm trying to the P flag here is port. So I am trying to what's the word again? Bind a port to the application. This application can be running on port 8080. I have no idea what the application is running, but I'm just going to let's just run this for instance. Let's just run it. Let's find out. So hopefully it's going to show us. So I'm going to run this application. It's going to show us a lot of things here. And now let's see. Just know that you don't have to build this. This is an application I built before now, and I'm trying to look at some of the things so that we just have an idea. So the port here is port 8080. So even if I were to go back here and try to, let's see, it's still showing what's it called again? Nginx. Why? So if I had to add, let's say if it's port 8080, is it going to show that? It's not going to show that. Because why? It is the Nginx is on port 80 or 8080, and this as well is on port 80. So that's like, so this one is masking the presence of this one. So one of the things you have to do is, first of all, understand the things running on your machine. So you could say Docker. How can you understand the image is running already or the container is running? Docker PS, you're looking at the process, so nothing is running. So in that case, we could come here and say, okay, fine. Now that we have run that, we don't want this guy, the Nginx here, because this is my local host. Do you understand? My local host, my local on my machine here. I don't want this guy to to look the application I'm trying to run. So then I can decide to say, let us add a port 3000 to port 8080. So now the first thing I'm entering here is the port of my host system. Is the port of my host system, and this is the port of the container I am running. So what it's saying is that I want, instead of this guy to display on port 8080, I want to display on port 3000 on my host system. The host is the machine, is the server that is hosting the what's it called, on which the Docker is installed. Do you understand? So I am saying I am opening port 3000 of my Windows PC, and I want to bind it to port 8080. So when I enter the IP address or the local host of my the IP address of my local host of my server, and add the 3000 port, I am essentially going to be seeing this application here, because I've been able to say you should bind to this. Now let's see how it's going to work out here. It's going to work out again. I'm going to come here and say, okay, fine, let's look at 3000 this time. So you see, we have the application now. So that's what the P does. The P, a map spot is saying, this spot here, I want to bind to here, so that when someone enters this spot, it's going to come out here. So let's exit. So we don't want to see these things all the time. We don't want to see these things all the time. These things can make, and we can't, and what is this saying? We can't do anything here because it's currently running. So what we can do, you can press Ctrl C and to get out of here. What we can do instead is come here and run it in detached mode. In detached mode. So when you run it in detached mode, you're not going to see all this nonsense. So you're going to enter this, and you see this is it. So you see the application is running. The application is running. So when I enter Docker PS, look for the processes that are running, you can see that this guy is running. You see, this is the ID that was given to the container, which is its container ID. This is the image exactly, and this is the command that starts the image on both. And how long ago was it created? 30 seconds ago, and it was up 11 seconds ago. And as you can see, I am binding. Let me just make this longer here. Let me just make this a little bit wider, just so you guys can see what I'm talking about. So I am binding port 3000 on the host to port 8080 on the container. So note the difference that if we are binding something, be it a directory, a config file, whatever it is, the first path or anything we are putting first is the host, is that of the host, and the second is the container. Then same again, then it's going to say name. And you should understand that you can always give this a name. And let's just say, let's stop this guy. Now we can decide to stop, we can use this name here that we given, or we can stop it with this guy. So let's call it Stoic Lamport. We have stopped this guy. So is there any, nobody's running? Then we can check all processes that have run, even those currently running and those that have been stopped. You can check with this. So this flag, Docker processes with A means all. That's the A flag. We are going to see everything that's run. So you can see we are seeing every container that's run here in the last how many minutes? This minute, in the last say 3 weeks, until you can remove this as well. So if I come here, this is going to stop. This is not going to happen again. So I can come back here and say, let's just start this guy. Start this guy. We start the guy again. And now we are going to see our favorite Java application. Voila. So while at it, sometimes when you are working with Docker containers, you may want to go into the application instead and see what's happening for yourself. So you want to see what's happening for yourself. You want to execute. So I'm not going to delve into that because that could be CI/CD. But here is what I'm talking about. Jenkins is a tool that we use to do continuous integration. So in this sense is that when you say you write your code and push to GitHub. Sometimes based on your organization's setup, it could be said that for every single time someone pushes a code to our GitHub repository, Jenkins is going to compare what it had before and what it has now. I'm going to say, there's been new changes, young man. And it's going to, what it's going to do at that point in time, it's going to build up a new image, a new Docker image, depending on how you configured it. Build up a new Docker image. And it's going to say, if you have a script that just runs the Docker image and they push it into a server, it's going to edit the script as well and push it in that set. So you have like a new application running without without having to do all these things manually. But configuring that can give you can take a while. But in that case, sometimes you may want to go into a server and say, this is what I want to see what it looks like. So I can go back here and try to stop. I shall stop this guy. So let's say Docker exec and look at IT. So this time I am executing the application and I want to enter into the application. How can I enter the application? Is by using IT. IT means interactive T terminal. So the interactive terminal, I'm going to see if I can go into Stoic. I can go into let's see Jenkins. So I'm going to go back at Docker images. Let's see. So don't run this. I don't want to run this. Don't want to run this. Which should I run? So Docker exec IT and B 6. It has to be running. Start again. Docker PS. So Docker exec IT Stoic Lamport. So he says, so when I'm trying to enter this running container. And what he says here is Docker exec requires at least 2 arguments. So what are the arguments? This argument, the name of the running container, and one other thing, and that is what the bash or the shell, whatever is running the shell of the container of the environment. So this bash. So we have entered that. So you could so this, if you notice now, this is the container, the inside of the container. So we are no longer on cloud practice. No, we are now inside the container, the container running the Java application within it. So yeah, if you are going to find out, it's quite minimal. So there are a lot of things that we are not going to find. So let's see. A lot of things I'm going to find. So you can see, let's see. So you can see there are a lot of things. There's home, library. So you won't find like a lot of things here. So it all depends. So let's go back. So Control D to exit, or you just enter exit, whichever. You can use Control D to exit or write exit. So that's how you enter the environment of an already running application. You enter Docker exec, then you use the flags IT, that means interactive terminal. Then you enter the name of the container, or you use the container ID. In this case, you can either use this ID. You don't have to enter everything here, and you're going to enter bash, which is good. So let me show you something as well. So that to show you that you don't have to Docker stop. I'm trying to stop the application now. I don't have to write everything. I can just say 43, and it's going to stop this guy here. It stops this guy because this is the only container here, and it's the only one that starts with 43. So if I were to check Docker PS, there's nothing running again. So that's like how powerful these things are. How powerful these things are. So let's move on to something we want to see again. So that brings us to another thing here, that when we talk about Docker networks, I'm coming. Let me find out this as well. So while I was measuring all the things that, all the things Docker had, paste this whole thing, yes. When I was measuring all the things that Docker had, as we saw when I opened the, if you can see when I opened this guy here, what all the things Docker have, you can see some of the things Docker have, you can see things like, you can see things like, let's see. So container. So container, unlike your normal PC or your Linux environment, does not have a file system. Instead, it has a virtual file system. Another thing it has is that it has, environmental configuration. So based on how you build figs, what it also has is that it has ports, just as we found out, running that application, it has ports. What it also has, let me see. Yes, the application image. So, and I'm going to show you what I'm talking about. If you see here, this is the application image for that application. So this is what's running. That's giving you this whole presentation. This is what's running. So it's running within that environment. So it has the application image. If it's not application image, this will not be working. It's not going to run. So those are the things that, the common things that Docker has, that Docker has, the four, things you're going to find in a container. And as I was explaining before, an artifact is an image. So it's only when you run it, or it's only when you run and it's deployed, it becomes a container. So it was noticed it's always only when we deployed this, we ran this Docker image, that's when it became a container. So yeah, that's the idea. And we've talked about all these things before now. So let's look at a little bit about Docker volumes. Docker volumes and basically why we would talk about Docker volumes. More like Docker networks and Docker volumes. Let's go down. So let's talk about Docker network and Docker volumes. So remember I said the Docker has a virtual file system. And when we are trying to run this application so that the Nginx is not going to overshadow what we are trying to see, what we did was we mapped the port on our operating system and linked it to the port on the container where the application is going to be running. If we were to leave it without specifying, it's going to run, it's going to say port 8080, it's going to say, oh, the one here is port 8080 and port 8080 and everything is good to go, but you can't specify. So in this case, instead of this, sometimes just so that you're going to persist, what would I call it now? You're going to persist, things. So take for instance, in this application, we had a database that was within the application, and we had stored the name already. See, we had come here and see, we are trying to set a meeting. We had set an event already here, and we stopped the application. We ran it again. Stop, not even deleted the container or anything. We just stopped the container. Then we started it again. What's going to happen is that the application, whatever was on that container, is going to go missing. You understand? It's not going to be persisted. So whatever was in that is going to stop and it's going to be deleted. So the VFS of your Docker, that is the virtual file system of your Docker, and linking it to the file system of your server, that's when persistence happens. So it's only when you do this, that's when it's going to be persisted. And one of the common ways I like to show this is when we do things, when we do something like a Docker, a Jenkins server. And I'm going to show, should I do that now? Let me see if I can do that. Do I need to do that? Let's see. Docker volume. Yes. Oh, we have a Jenkins home here already. So if you notice, here's what I'm trying to talk about. Here's Jenkins home, a server that a volume I created when I was trying to run a Docker, run the Jenkins server. So what's happening is that every single thing I did on the Jenkins or using that Jenkins server is still stored here, even though the Jenkins is not running. If I can delete this Jenkins now, and this volume is still going to be here, I can pull a new version of a Jenkins from Docker Hub, run it, as long as I am going to link the virtual file system of the Jenkins server within the container, link it to this guy here, which is outside, which is on the host. And I'm going to have the same things I stored on that server here. That's the idea about volumes. So volumes, ensure that persistence occurs. And that's how we use them within the workflow of Docker file. So I could pull this thing here and move it somewhere else, and still going to, as long as I link this guy to the new Jenkins server, no matter how old, no matter the version or whatever it is, it's going to show the same things I had done on there. And that's where this thing comes in. So Docker networks as well. I'm going to show. Is anyone trying to ask a question, please? Is there anyone trying to ask a question, please? Please mute your mic. So I'm going to take it like no one trying to ask a question. So there are several also for networks, just as we have like volumes are used for persistence. So for persistence, and networks are for isolation. For isolation. So when do you, so there are three different networks when you are trying to for Docker. There's the you have the bridge. There are several networks, not just three anyway. There's the bridge network, there's the host network, then there's the Wale network, there's the Mac VLAN network. There's also the non-network, but then again, I'm trying to explain all these things. So think of this. Let me just find somewhere to pull out this guy from. So let's delete these guys. So come here. These guys are all friends. Let's say these guys are friends. They all went to the same, same primary school, secondary school, best of friends, and they all went to different parts of the country for their university or their undergrad study. And they have, let's say they have a walkie-talkie. Let's just say they have a walkie-talkie. In this case, even though walkie-talkies are not good for are not good for great, great expanse or great wavelength, but this is they're using like a walkie-talkie, or they have like a smartphone that that you have like specific frequency where they can talk to each other. So let's say this person here, let's bring this guy here as so. So yeah, so this is it. So you have, see these four guys here now. So each of, so let's say we all have, let me see, these guys here. So a bridge network is going to take like a private channel. So let's say all these guys, channels, this guy is talking to this guy. It's a two-way thing. And this guy is talking to this guy as well. Let's just call this guy talking to this guy. This guy's talking to this guy. Let's just say their things intersect as well. It goes both ways. So it goes both ways, how they're talking to you. These are private lines. So anyone can try to call. And let's say someone can be here. Let's bring someone here who's not in their friend group. And he's trying to make a call to say he's trying to intercept here. He cannot, because he's not on the same frequency. He's not going to be able to listen to their calls. So that's what like a bridge network is. It's like a private channel for friends, back and forth. But only those in the group can communicate. So if you have let me make this even clearer by bringing in bigger stuff here and say, trying to do is, so this guy come out. I hope this is clear enough. So only those within this whole thing here interact. Let's say all these guys are containers in themselves. Only those within here interact with it. So that's what like a bridge network is. So a bridge network is like setting up a private walkie-talkie channel for these guys, and only those can communicate with each other, and they can't hear anyone outside. That's what they are trying to do now. So when you start a container without specific instructions, just like we did here severally, without specifying the network, when we start the container without specific instructions, it automatically is connected to the bridge network. So come here and say Docker network and list it ls. You're going to see the bridge, host, and none and null. Those are the drivers, and these are the names of the network. So I'm going to pull this here so we can be able to see this as we move forward. So it's automatically connected to a bridge network, which is this. And the bridge network is a charger now that allows containers on the same host, which is the same host. They are all the same host. Containers on the same host to speak with each other and to talk to each other directly. So you don't have to go through like a channel or anything else. So an example is like a web server or a database. So sometimes you may want, in terms of for deploying a 3-tier application, for those who understand what 3-tier application is, 3-tier application are those applications that have a database, the business logic portion of the application, and the front-end portion of the work of the application. They are in 3 tiers. Those are 3 tiers. And what you want to do is you want to keep your say your backend, the backend application, the backend and the database quite separately, because sometimes when people get access to the backend of your application, they can query with the API and get people's details, credentials, and all that stuff, depending on how you may have worked on the API or whatever is acting as the mediator between your backend and your database at that point in time. So if someone is able to get into your backend or your database, that's automatically doomed for you. And in some countries, that's like you're going to get a lot of litigated. You're going to get litigated for that kind of trouble. So to preserve that whole the serenity of your application, you'd want to put, say, your front end somewhere else, and we want to put your front end. You want to put your front end, let's just say this guy now. Let's say this guy now is the front end, and this guy is here at the back end and database. So you want to put your front end. So even if a malicious actor got access to your front end, they cannot go back to your back end, because this guy you have put such a way that you don't want to expose. So that's like the idea. You have this small web application with 2 containers, and since the container needs to talk to each other directly, and you don't need them to be visible to the outside world, you don't need. So you could just say, "Oh, let the guys talk to each other. I don't want anyone else to be able to see how they're talking to each other." So you can. So instead, just as we have here, you can tell to create a network. Let's say to create a network is a Docker network. Let's just say let's just say front end. Create front end, and let's just and when we enter Docker ls again, we have the front end guy. You see that the driver is the bridge and the name is this. We did not specify what it is. So even if you don't specify, it's going to automatically create a bridge for you. So if I want to run something now that I want to I just want this guy to know, I can say, okay, I want to run Docker run this guy. Let's just say the version 4. Let's just call this. So which network do I want to network? And I want to say front end. And let's just call this guy meeting app. The name of this application is called meeting app. App. So this is how to. So instead of here when we are trying to this name here, this twig lamp port, if you don't specify the name of the application of the container, Docker is going to slap any cool name it finds, or it can generate on its own and give to you. So when you use a name like this, you are saying, I want the name of the container to be called meeting app, not strict Lamport. Then you can say, I want to also add port 3000, and if you got ATT, then it should be, let's just say it should be in detached mode, and boom, you're going to have what you want to have. So if you come here and say things like this, let's see if this guy's going to work. So it's going to work. So yeah, this is the guy. So you can see Docker PS. You see the name is meeting app. That's been up for like the last 17 seconds. And where is it now? It's in the what was it called again? It's in the front end bridge. So that's how it works. So let's go to host network. So just as we have here now, just as we are showing here, just as we are showing here, the host network is like sharing the same frequency as your home intercom. So instead of these guys having phones together, instead the house in which they are is the frequency. So whenever they are in that house, they can speak to their friends who are in other homes. I don't know if that makes sense. So the host, so the way what's housing them is owns the frequency, not the phone, not the walkie-talkie. So as long as you're in that house, you can hear anything. You can hear anything. So I can talk to myself. My neighbor walks into their house, and they can easily hear what we are saying as friends. So it's almost like it's loudspeaker. So if you have tried to talk to a friend and you put it on a loudspeaker, anyone enters the room can hear what you guys are saying. That's the same thing for your host network. So when you attach a container to the host network, it doesn't get it to an IP address. It uses the IP address and the host own and the port of your host directly. It's not going to say, here's my IP address or any other thing. So this setup removes what we call, one of the things we are talking about Docker from scratch, we're talking about the isolation process. That's the isolation. We are trying to isolate Docker as, in some cases, we want this concept to run on its own without any external, issue from anyone. So the setup removes the network isolation, and sometimes what this does is that because it's not isolated again, your Docker machine, the network, the IP address and the port are primarily the same thing because you are running it on the host network. There is less latency. There's less latency. Latency in this case that, so take for instance Call of Duty, when you're trying to shoot someone, you have pressed your trigger button like 2 seconds ago, and someone just comes and shoots you and moves away. Your bullets are still not left in your gun. That kind of thing, that latency kind of stuff. So that's like the idea. So when there are a few times when using the host network is advised, and that is when you are deploying for like gaming studio, like gaming servers, like high performance applications like games need like every millisecond counts. Like do you understand? So you don't want a delay between the container, the response leaving the container, traveling through the intersection and going to the ports. No, you don't want that. You want everything to go as at when it is done. So when you use your network, your container can directly bind to your host network, and it's making it faster and simpler. So the only downside to this is that just as we remember when we were trying to when we run the application, it was in port 80, it was connected to port 880. We could not see could not see the application because there was port conflict. That is always going to happen. So just know that instead you cannot specify where that port is going to run on. You cannot specify that. So when there is like a clash of you're trying to run multiple applications on such a server, then just hope and pray that other applications that you have run before then do not use the same ports as the ones you just running. So does it make sense, everyone? Do you understand so far? Do you have any questions? Please leave a thumbs up if everything has been clear so far. If not, everything has been clear, just ask a question right away. So everything has been clear. I am going to assume that. So So let's see what we're talking about. So to set up the command, you would have to, like just like before, you're going to say, just as we said, now we cannot create a bridge network. We cannot create like like how we created front end here. We cannot create a bridge network. Instead, we can run it. We can say it's a Docker run instead of a network, instead of the front end here. We're going to put host and run in detached mode. And we are going to remove this whole thing because we don't effing care at this point in time. We do not care because we are not trying to, put that difference, to just for when you are running something as a host network, you do not put this portion with it. So you just bind directly, come up directly with it, and that's how you have it. I do not want to bind anything with my pod right now, so we're not going to do that. Then there is the overlay network. So think overlay network is you connecting with friends in different locations. So I'm coming screen. So just as we explained before, that the host network is just like you being in one house and you guys talking. The overlay network is people being in different houses, different places, but you're all on the same private channel, almost like I explained with the bridge network. But in this sense, you guys are in different locations. So, but the idea is that now you're in different locations, even though you guys are talking, you don't want anybody to peep in. So you have to have like a secure internet chat. So just like you have a WhatsApp group chat, nobody can snoop in, and unless they have your phone, your password. Nobody can snoop in your WhatsApp group chats with your close buddies. That's the same thing with overlay networks. So an overlay network is used when you are trying to connect containers across different Docker hosts. So think of it as, think of Docker hosts as different PCs in different parts of the country. But you're trying to ensure that the Docker containers running on these different PCs in different parts of the country are running securely. So this is really cool when you are running, say, clustered environment clusters. It could be a clusters of containers where you want them the communication within with their containers to be the same thing, even though they're in different locations at the same time. So this is very needed for like large microservices, like when you have tons and tons of microservices. Like think of Netflix now. Netflix, you have several hundreds of thousands of microservices to ensure that it's smoothly running. So it could come from, you could say, what are these microservices? The front end is different. The microservices for recommendation is different. The one for video streaming is different. The one for user interface is different. The one for search is different. The one for your parts, if you're buying movies or renting movies, is different. So you understand, like all these things are microservices, and they could be running on different machines, different servers, different availability time zones for those who are familiar with cloud environments. And you can only use an overlay network when you want to connect them into one big private network. So it's like it's like me understanding that wherever this person is, that's where my land stops, that kind of thing. So I don't know if that makes sense or any of you. So you can create an overlay network the same way, but this time you can say Docker network create and the overlay network. It's as simple as that. But this time you would have to use the detached mode. So it's the same thing here. And like this is an example. So that's how to create like an overlay network. Then the Mac, then let's pull that. I think we have everything those things I have written all as well. Let me see. So you have the bridge host, you have the overlay, and this guy here. So this network is like giving each of your friends their own mobile phone. So now you're not work is okay again, and you guys are using mobile phones. So now you guys are, because in frequency, like for walkie-talkies, you are seeing you guys as one entity. For mobile phones, you guys can be using any network of your choice. It could be Glo, MTN, whichever network you're trying to use. It could be 3, anything you're using. And they're not orange. They not appear as separate entities. But on the phone network, you can receive calls directly. I don't have to talk to everybody at once. I can talk to one person at a time. Or I can talk to everybody. That sort of thing. So Docker is going to assign each container its own unique IP and MAC address. That's what this guy does, this network. So when you put this guy's create this network, you need to have things like your subnet already configured, your gateway, and every other thing as well. So it assigns every container its own MAC address, its own IP address, and makes it look like a standalone device on the network. That kind of thing, like how you have like your own, and making it look like its own computer in a very large network. That's what this thing does. So I have heard of some instances where I've used I've never really used this like in real life, but a common example I have read about what has been how we use legacy applications that require a direct IP address for each instance to communicate with other devices on the local network. So I want a traditional printer, like how you want folks, just like you want your PC to talk to a printer, like that kind of connection. That's the kind of thing you're going to have as well. So when you use a MAC VLAN, a network, each container gets an IP address on the local network, and all that devices can target it as a separate physical machine, just as it would with a hardware machine, that kind of thing. So here's an example. Let's see if I can do something. So Docker network create VLAN. If you are trying to write a multi-line, what do you call it again? Let me see if this is going to work. Well, I'm coming. I don't want that now. You're trying to write a multi-line command. This is how you use it. So you're going to see. You're going to write the subnet, and you're going to write whatever you want to write. 1, 2, 3. Oh, sorry. 1, 2, 3, 4, 5, 6, 7.8. Then do something like 24 or something. This is like just an example. Then you're going to enter the gateway and see, just specify same thing again. 1, 2, 3, 4, 5, 6. .7.7. Let's just see. Parent is equal to ETHO, and see what's the name of the network. Let's just call it MAC VLAN network. And that's how it's going to run. So this is how you're going to run it. Simple as this. And that's how you can create one. I don't have any to create one. I don't want to use it. So that's it. And there is the last type of network. We have talked about different networks. The last one here is non-network. The non-network is like taking away your friend's walkie-talkie. Like, you're saying, hey guys, no more walkie-talkie for us again. I don't like I use walkie-talkies and phones. And they're cut off. They're cut off from the group. So this guy may have messed up, may have snitched on you guys or something like that, something similar. And he says, guy, you know what? Let's get this guy out of our group. He's no longer with us again. He's no longer with us again. So now, let's see how this is going to fix it. So let's see. Is it here? So let's say, oh. So the guy is now, so this guy can no longer be on this network. So this now is a non-network. They can only talk to themselves. So in Docker, connects to a network to a non-container, to the non-network means it has no network access, no internet, no communication, nothing with other containers. It is completely isolated. This is like the ultimate form of isolation. So This is usually advised, or usually is one of the ways we tend to deploy or run containers where there are sensitive data going on and doesn't need any external connection. You don't want anyone from outside who's not the DevOps engineer to have access to that container. So it's typically those kind of containers that so when you use the network, you ensure that the container is fully isolated from the environment, from the network, and it further improves the security of your deployment process. So you can also have things like what was the word again? Just like we have, I told you before, guys, like how I created this guy, how I named this guy this meeting app. So if I had other applications on this or other containers running here, and I wanted them to bind with this guy, I would just say just bind with this guy called meeting app. I don't have to specify their container ID or their excuse me, or the image ID. None of that. So that's like the idea of DNS. This is like Docker's own version of DNS. So do we understand so far, please? Do we understand? Guys, do we understand? So please leave a thumbs up if you understand. Let me see if I can. Do you guys understand? Do you have any questions, guys? Do you have any questions? So I am going to assume you guys don't have any questions. So let's look at something quite cool. And that would be writing Docker. Let me see. Docker. I'm writing Docker files. So let's see. So, can you guys, is this large enough? Are the characters legible, please? Let me know, are they legible?
Sure, bro. Sure, bro.
Okay, thank you.
Bro, but you might like to increase the little.
This one, the VS Code.
VS Code, yeah.
Oh, let me see if I can increase that. Come in, let me see if I can increase that as well. It's going to be very, very hard. Come in. I don't know. Is it better now?
I think it's the same thing.
So I think this is a little bit.
Yeah, it's okay.
This is a little bit legible. I'm trying to find. That. So this guy here is this is the application that I built. This is the application, not that I built early, but the application that I containerized and turned into this guy that we ran earlier. I think this guy is still running. Let me see. Docker PS. Sorry. Oh no. Docker PS, yes. Docker stop. meeting up. So stop tears. So so we're going to see now. So this, excuse me, pull this thing here. So when you are trying to create a Docker file, one of the things like how do you start to create a Docker file? You are going to say, first of all, Docker file. That's it. So a Docker file, this is how you start your Docker file. And to understand how to create a Docker file, you have to understand the kind of application you are running with. And you have to understand the kind of base image you want to start with. So here's what I'm trying to see. Let's pull up this guy here. And here we had, well, please. Here we had, say, let's look for Docker, let's look for Java. Or OpenJDK. Let's see. So you can see we have, you can say OpenJDK, there's 25, there's this, there's Alpine, let me see Slim. You can, let me see Slim. How many? I have to check how big it is, because that will give me an idea on how we're going to do that. So I can find how slim it is, how big it is, nonetheless. So just as we see, every Docker image is a Docker image. It's like a Docker file. It's a Docker file, and I'm going to explain. This Docker image here, this Slim, when I clicked on it, it directed me to this GitHub repository, and here, this is Docker file. This is Docker file for that Docker Docker image. So it's kind of pull this to your local machine, and when you run it, it is going to do what? It is going to run using this is a command that runs the application, basically JShell. This JShell is the ultimate command that triggers everything here to run as it should run, and that's when it becomes like a container. So every image is a Docker file, and you can create your own Docker files, and that's what we are going to be looking at. So we can come here and say, oh, which other thing we're going to look at? We can just enter this one now. Same thing. It's a Docker file, all of them. The only difference most likely would be where with the from portion and a couple of things. This way you know that's where everything gets started from. So if you notice, this is a Microsoft version. If you look at the Slim Bullseye, it's most likely going to be based on the Debian Bullseye. What is it called now? Distro. You see, it's based on Debian Bullseye distro Slim. If you go somewhere for Oracle Linux, it's going to be based on Oracle Linux distro. You see, so all Docker images are based off of Docker files. So that's like the first way six. So so how do we start from here? So let me pull up. I'm trying to so we could say from base image. So what's the base image are we trying to use? I am trying to look for something that is that is slim and that is not going to take up a lot of space. And here's what I'm trying to say something but taking a lot of space. When you enter Docker images, you're going to see that this guy here, the OpenJDK alone, is about 504 MB. Much less the so before we move and add other applications to it, you are going to be seeing that we are going to have how many applications how large is that going to be. So you're going to be having a large application. You can go look at size as much as 1 gigs or something, and you would have to push this to your Docker hub and pull it back, sometimes depending on your workflow. So that's something you're going to be thinking about, as even as you are just starting out and you want to ensure that you don't have to use as much data plan as possible. You're going to use a data plan regardless, but I'm just giving you a heads up. That's what's going to happen. So I can say, let's use the OpenJDK, the 21. Let me see. This usually have 21 because it's let me find the tags. I'm trying to find something slimmer because usually if I were to run something, I'm trying to look at Alpine. Alpine is a little bit slimmer and makes it usually very, very. Let me just see if this guy's going to work as intended. 21. I'm trying to find more. Show me the tags. 21. Show me Alpine. No, not this one. I'm trying to find JDK. Show me 21. Alpine. It's any Alpine here. So let's see. There is no 21 JDK Alpine. Hopefully this works. Let's see what's going to happen. So now open JDK 19 and JDK. I'm trying to use this guy here because this is going to be promising to be a lot lesser in terms of size. We are going to build both Docker files. We are going to build both Docker files. So let's say open JDK 19, 3.16. So this, yes. So now it's saying using this base image, that's what I want to do to build my own application. And when we run the application, this application, you must have run it using Gradle. Gradle is a build tool for Java. There's Gradle, there's Maven. And you must have installed Maven or Gradle. You have to understand which one. So if you look here, you see MVN means it's Maven. So it's Maven wrapper. So you're going to use Maven to install this. So that should be, so you have to understand how to deploy these applications manually or build them manually before you understand, go over to Dockerizing them or containerizing them. So I want to expose this, this port I want to expose when the application eventually runs. And I want to say, okay, they work. Let's just take this up instead. Let me just put this before them. So the work directory. So which part will I use for the work directory? Which part? Sorry. Which part will I use for the work directory? So let's call the work directory. I can decide to use the full stop, meaning the home or whatever I will call that, but I want it to be in the user source application. So this is going to be the work directory. So this is going to be the reference directory within the container where we are going to be copying or doing any other thing. So anytime I'm going to explain this, so I choose this. I can decide to choose, say, this or something like that. But I'm choosing this. This is what I'm choosing. Like this is me. Or I can decide to choose, say, app. So it all depends on you. So I'm choosing this work directory. And we could come here and say, oh, let's copy this guy. Sorry. Let's copy this guy. Let's copy the guy in the target. Who's in the target? We did not build anything here. We can try to build target. There's really nothing here. So we could come here and say, how do we want to build this application? So let's see. Is Maven installed? Sorry. Is Maven installed? So Maven, who's speaking? So Maven package. So let's see what's going to happen. So Maven package, I have Maven installed on this application, on this. I have Java installed. I have Maven installed. So that's the reason I'm able to build this tool. So I'm trying to build the application now, the application in which I am going to copy from here and put here. And let me explain this from the whole beginning. So this is the application. This is the application. Yes, we have all these things here. And you see mvn.mvn, the Maven wrapper, you have the Maven command, the pom.xml that has all the pom.xml basically has all the dependencies. So you want to look through here and see what's the Java version, if it's written here, or the Maven version you need to download. Then you want to look at any other thing you want to write about. So basically, this is what these are for. So basically, you can only run this application if you have Java installed, and certain Java applications, certain Java versions do not go with certain Maven. So you have to install the right portion of the Java application. So if I were to come here, is this the building for me? So if I were to come here and say Java version, it's going to tell me Java 21. So I have OpenJDK 21 installed here, and I have what's it called again? I have OpenJDK installed, and I have Maven installed, and I have Maven version. I also have Maven version installed 3.6, which is based on this Java version. So you have to install the Java first before the Maven, before installing the Maven. Same thing when you're installing, if it's Gradle that your application is built on, it's going to be built with, you have to install Maven, Gradle. So you have to understand how to deploy your application by your own manually before you are able to do this. So here I'm going to say, oh, this person already has this thing installed, Java installed, and Maven installed. That's how I'm going to build this tool. So to build this tool, I had to use Maven MVN package. Let's see that again. Maven package. So yeah, that's how to build the app. So now I've built it. Let me see if there's that. So you can see that this guy is there. I see the jar, the .jar. That's the artifact name. The artifact name. So what's going to happen is now we are going to come here inside this place, move only the artifact. That's the only thing we need to do. So basically, this Maven condense this whole application and put it in the jar file so that when you run it, it's going to come out the way you want it to come out. Do you understand? So we could come here and say, okay, let's copy. What are we going to be copying now? We're going to copy. We're going to go into here. So since we are in this, you should understand the relative parts in what's it called now? Understand relative parts in Linux environment when you're trying to go from here. So by use full stop means in this same directory, I want to go to target, and I want to pull out this guy. So you can see, let me see, copy relative path. Let's see what's going to happen. So you count. So basically, so this is it. So copy this guy, this whole thing here, and I want to go here and put full stop. So what does this mean now? Like I told you, this is going to be our reference path going forward, our reference path. So basically, I'm copying this guy from here to here. So let me tell you what this guy is doing. So I have built and say, oh, on OpenJDK 19 with all these things, using this as a base image, I am going inside here. I am opening this folder. This folder I'm opening this folder. I'm going to say I've opened this folder now. Now, when I open this folder, I am seeding into it. Someone saying something. Mute your mics, please. So, what directory here does is saying that within this base image, I am using this guy as my work directory. That's where I'm going to be doing a lot of the things, all the things I'm going to be doing now, unless I state otherwise. So now that I have opened here, now open the carton. Let's just say this is the carton now, and I am copying something from here into the carton. So we are saying the carton is where we are now, but we are copying something from here into the carton. Does that make sense? I'm trying to show you what it means. So even though I'm copying something from the host into the container or into the image, that's all basically saying, so to this full stop. So this full stop means referencing this guy, while this whole thing here is referencing this guy here. So yeah, I'm copying this into here, and now I'm exposing port 8080 because that's what the port is when they're developing it. That's the port that was what's the word again? That that our application is targeting. So we are going to use CMD. CMD is the command, is the executable. Now we are going to what's the executable of the application. So to run a Java application, that a Java artifact, you write Java. You write Java. So basically, if I wanted to run this now, I would have said, "Oh, I'm going to target," and you see this is application. I want to run it. I'll say Java, jar, then Springboard this. This is how to run it. This is how I'm going to run it. But here, so I'm going to do here is to how am I going to write this with in the Docker file is I'm going to write Java, comma, jar, another comma, then this guy here. So I'm going to copy this guy, then this guy here. So this is how it works. So just like this, we now have a what's it called again? So let's see ls, let's see cd. Sorry. I'll keep turning on my calculator, sorry. cd. Let's see now. We have Docker file. That's Docker file. So basically this is it. Let's create something now. Let me see if I. So basically this is it. So this is what we have now. So you can choose to build this guy now. How do you want to build it now? How do you build your Docker files? You're going to say Docker build. You can tag it. So tagging the application depends on what you want to name it. You can sit up and click on full, and this is how you do it. Or there are a couple of, let me just find like a couple of ways, a couple of cool ways we can do this. Where is that again? Finding see. So let me just say this. You can say Docker build T. We are trying to target. Now, target is the name we're going to call it. So since we are going to be if I were to log into my Docker container, my Docker hub, my username is Gideon is building. That's my username. So I would say if I want to name this now, since I'm going to be pushing it, I can say Gideon is building and who default to the name we want to say. I'm calling it, let's say meeting. Let's just say Java meeting app. Then I may call it say version 1.0.0. Then full stop. So what's going to say? I want to build a Docker image with this tag. This is the whole tag, and full stop means this is where the Docker file is located. Full stop means the Docker file is located in the current repository. That's what this is trying to say. That's what this command is trying to say. So unless we do that, that's what is going to show up. So let's see if this is going to happen. So let's try and build right now and let's see what's going to happen. So let's take note. Docker images. Sorry. Docker images. Knows the tags and knows the name of the app. So we could just go back and say, fine, let's build this and let's see what's going to happen. So it has started building. Let's see. So let's see what we have successfully built the app, and now let's see Docker images. If you notice, Gideon, this is the app name we chose, Java Meeting app, and we call it version what? 1.0.0. And we just built 25 seconds ago. Look at the size, difference between this and this. So these are the two. I just showed you like how we build it. So if I were to use something like just as we showed you earlier, if I were to use something like I use Alpine, if I were to use like a simple thing like come here, overview, say use 21. Say I had to use 21 or 25, whichever of the Java OpenJDKs. Here, if I had to use 21, say if I use 21, say 21, and delete the rest, then we would have something as minimum this level. But now, just because we use this now, just because we use this, that's why we have something as simple as you see. We are able to achieve almost half the size of this by simply this thing we chose. What's it called again? By simply what's it called again? The base image we chose. That's one of the ways. That was one of the best practices of building Docker, writing Docker files and building Docker images. You have to be careful and wary of your base image while building. So if we were to, let's just see this works out now as planned. Say Docker run in detached mode, and let's call this Alpine app. Let's call this Alpine app. Sorry. So notice that if you are using one, most times if you're using one hyphen, you write D, and if you're using two hyphens, you write it in full. So that's something you should take note of. Then 3000 to let's remember that. Come here and see. Come here. Let's put it this way now and see. If you notice, this guy is not going to run it again. This guy not, so you can say 3000, but 8080. Then what are we going to be saying now? We're going to be saying again is Java Meeting app version, this guy. So Docker run, detached mode, name, Alpine. So let's see what's going to happen. Boom. Is this going to work out? Hopefully. Is it going to work out? The only reason it might not work out would be we have a mismatching image. Let's see. Coming. We have a mismatching image. That will be the only reason. Let's try one more time. So work. That's the reason it might not work out. So you should notice that the only reason why this might not work out is because, take for instance, here I used what's it called again, which is very, very quite different. When we check the Java version, you see Java version was Java 21, and the Maven was compatible with the Java we built on. Sometimes, even though say Java applications and Java files are backwards compatible with applications and with the versions of the Java, but sometimes you have to be very careful to understand that whatever the things that are used within the to program the file, that certain features that are used are very specific, are present in the ones you're using. So that's like the only way. So we have been able to build like I showed you in theory or in practical, we are going to build a smaller, almost half the size a container by simply swapping out the kind of what's it called again, the kind of base image we used. So I think that this is going to be like a sweet spot for us to stop. Any other thing else would be information overload at this point, because we would have to look at things like say Docker Compose and all of that stuff. But I think we are going to get to like a quick, like a very cool, a very cool, middle ground. So I think that will be all for today. Do we have any questions, guys? Do we have any questions? Guys, do you have any questions? If you have any questions, please signify. Do you have any questions? Okay, I am going to assume you guys don't have any questions, and like I did a cool job explaining to you all Docker all through from the basics, networking, the volumes, and up to writing like a simple Docker file on containerizing a Docker a Docker image. So I think that'll be all for me for today. Okay, do you have anything to say? Do you have anything you want to add, please? Thank you.
I think for my own end, I really have nothing to say. So on the WebEx, I'll probably just drop I'll drop a link for them on the WebEx. I think I already dropped it anyway. So it's just more of self-paced where they can, practice just like we did for the bash scripting, for them to practice and use that to be able to, understand the concept of Docker files and every other thing required to be understood using Docker. So I think I'm good on my own end.
Okay. So let me just paste the link again once again. And so that's the link you got in the Docker in 2hours space. So you could just go there and look through it and see some of the things you'll be updating the repository as we go through, but just go through it and just play with it. So thank you very much for today, guys. Thanks for listening. I do hope you guys had a wonderful time as I did myself. So good night. Bye-bye.
All right, guys. Thank you, everyone. See you some other time. Do have a wonderful week ahead.